Okay, so in this video we're talking about solving linear systems by graphing. And so what is a system of linear equations? Well, all it is when we are examining two or more linear equations at one time. So we're looking at two or more linear equations at once. And then a solution, what does a solution look like? Well, we have lots of possibilities. If we have, let's just pretend we have just two equations. Okay? Well, we know the lines can cross at exactly one point. They can be parallel and cross at no points, or they could be sitting on top of each other and cross at an infinite number of points. Well, here, fortunately, a solution to a system of linear equations is just the set of intersection points. So if it crosses at one point, then there's one solution. So it's the set of intersection points. So we're looking for the set of intersection points. And so what that means is we have three different possibilities. If the lines cross like this, then there's only one intersection point. The one intersection point is the solution. So there's one solution because there's one intersection point. Okay, if the lines are parallel, well, parallel just means to never cross, so that just means there's no solutions. So zero solutions. Which just means there's zero intersection points. And then finally, if the lines live on top of each other, meaning that they're essentially, for all intents and purposes, the same line, they live on top of each other perfectly. So here the red line lives on top of the blue dotted line. That means there's an infinite number of intersection points or an infinite number of solutions. So there's an infinite number of solutions, which means there's an infinite number of intersection points. Now this 8 that's turned on its side, that's the infinity symbol, in case you haven't seen that before. Okay? Alright, so we know that a solution to a set of linear equations is just the point or points that satisfies every equation in our system. So what we're going to do here in this example is we're going to test a couple points. And we're going to determine, are they solutions, yes or no? To be a solution, it has to satisfy every equation in our system. If it doesn't satisfy every equation, then it's not part of the solution set. So let's do the first one. We'll do the first one in red. So the first order pair is 2, 2. So everywhere I see an X, and everywhere I see a Y, I'm going to put in a 2 for both equations. So I'm going to test the top one. So we have 3 times 2, which is 6, minus 2 times 2, which is 4, and that's supposed to be equal to positive 2. Well, just simplifying down, we find that we do have 2 is equal to 2, so the first equation is satisfied. Now for the bottom equation, everywhere I see an X, I put in a 2, everywhere I see a Y, I put in a 2, so I have plus 4, and that's supposed to be equal to 6. Simplifying down, we do find that we have 6 is equal to 6. So both equations in our system are satisfied by that ordered pair 2, 2. So 2, 2 is part of the solution set. So yeah, that point works. Let's go through and try the second ordered pair. So for the second ordered pair is 0, negative 1. So everywhere I see an X in my system, I'm going to put in a 0. Everywhere I see a Y in my system, I'm going to put in a negative 1. So let's go ahead and do the top equation. So I have 3 times 0, which is just 0. Minus 2 times negative 1, which is just going to end up being positive 2. And that's supposed to be equal to 2, which obviously that's true. So 2 is equal to 2. So the top equation is satisfied. Okay, but now we need to check the bottom equation. So I have 0 minus negative 2, and that's supposed to be equal to 6. Well, clearly, negative 2 is not equal to positive 6. So the bottom equation is not satisfied. So that means that the point that 0, negative 1 is not part of our solutions for this system. Okay? Now let's go on. So we want to solve this system by graphing. Now, both equations are written in standard form, and you could graph them in standard form by using the x and y intercepts. However, I do find that it's a little bit easier, especially if you want to use your calculator, to go ahead and graph them in slope-intercept form. That's just my personal preference. You do what's easier for you. Okay, so I've already gone ahead and got both equations in slope-intercept form. That's just by getting y by itself. You should be able to do that, so I didn't work it out for you. All right, so what I'm going to do is graph both equations now. So the top equation is represented in blue. So I have I'm just going to, since I have fractions here, I'm going to just do a table of values so I get to pick some nice points. Oops, and that should be a y. Okay, now I want to be smart with my choices here. So I want to pick something, I don't know, let's try maybe x equals 5. Okay, so x equals 5, I have 10/3 minus 1/3, which is 9/3, but 9/3 is just simply 3, so y equals 3. So x equals 5, y is equal to 3. Okay, let's pick another point. Maybe x equals 2. So x equals 2, I have 4/3 minus 1/3, which is 3/3, or just simply 1. And then finally, let's pick so x equals 2, I got y equals 1. And then finally, let's pick another point just to be safe. Maybe x equals -2. So x equals -2, I get negative, or maybe not x equals -2, excuse me. Let's do x equals -1. All right, so at x equals -1, I get -2/3 minus 1/3. Well, that's just minus 3/3, or just -1. Okay, so now if I had a yardstick or something like that, then I could just connect my dots really, really nicely. So I'm going to do my best, and that's pretty terrible actually, but it'll go for our purposes. Okay, so that's the blue equation. Now again, if you had a yardstick, that line would be a lot straighter, okay? So just, you use a ruler on your work. All right, and now for the second equation in our system, y equals -x plus 3, I can also do a table of values if I want to, but I know my y-intercept is +3 and my slope is -1, so that means I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, and then going in reverse, up 1, left 1, etc. And so I have several points on my line, and I can see clearly I do have a really nice intersection point. I do have a really nice intersection point here right at 2, 1. So this intersection point right here, that's the solution, 2, 1. That's the solution to the system. So x equals 2, y equals 1. And it was just the point where those two lines crossed. Okay. Now we want to look at this equation and tell how many solutions should this linear system have. Okay, well the only way to really do it is just to go ahead and graph it. Like we did on the previous problem, I'm going to go ahead and get y by itself for each one. So the top equation I'm going to do in blue. So to do that, we're going to have our 2y is equal to 3x minus 6, and then get y by itself. So we have y is equal to 3/2 x minus 3. And then we want to get y by itself for the second equation. Okay, so I have, let's see, I have 6x, oops, let's get 1 on the left-hand side, excuse me there. All right, so we have 4y is equal to 6x minus 12, and then divide by 4 on both sides. So we have y is equal to 6/4 x minus 3, or we can just simply reduce this fraction right here down. We have y is equal to 3/2 x minus 3. Or you probably have already noticed is, hey, I got y by itself and I have the exact same line. These two are the exact same line. So what that means is those two lines will sit on top of each other when we graph them. That means there's an infinite number of solutions. I didn't even have to graph them. Now, if you had your graphing calculator, you could verify this by graphing both equations. But what you'll see is only, quote unquote, one line, because the lines are sitting on top of each other. So they have the same slope and the same y-intercept, so those are the same line. So there's an infinite number of solutions. So the answer here is just an infinite number of solutions because it's the same line. It's pretty easy. Okay. How many solutions does this system have? So we're doing the same type of thing. So what we're going to do first is get y by itself, just like we just did. Okay. So for the first one, I'm going to do that one in blue, get y by itself. So I have 2y is equal to 3x minus 6. Get y by itself, I divided by 2, so we have 3/2 x minus 3. And for the second equation, get y by itself. So I have 2y is equal to 3x minus 2. Okay, so go ahead and get y by itself. So we have y is equal to 3/2 x minus 1. All right, so now we know we don't have the exact same line, so we know it's not an infinite number of solutions. But what we need to also pay attention to is, hey, here in these equations, the slope is the same. We have a slope of positive 3/2. And what we learned in the previous chapter is when two lines have the same slope, the lines are parallel. So these two lines, when we graph them, if we graph them, the lines are parallel. But since I recognize that, I'm not going to graph them. Okay, because the lines are parallel, what's the point at this point? Because we know when the lines are parallel, that means there's zero solutions. The lines are never going to cross because, so there's zero solutions because the lines are parallel. Oops, I spelled that wrong. Okay, there's zero solutions because the lines are parallel. Obviously, the definition of parallel lines are two lines that never intersect. All right, that's it for this video.